Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after a lot of trial and error and a lot of struggling, so I'm really happy about this. Again, this one was not easy due to the edge cases. You can see I sat here for a while trying to solve it, and I finally was able to come up with my own solution to it without any assistance, so it was worth the sweat, I guess. So let me show you how I did it. Basically, you have the question itself, again, is pretty simple. Just find two indices that satisfy this condition where they're at least this distance apart and the absolute difference is at least this much, and then return those indices, and -1, if it's not possible. So obviously the first brute force approach is really easy. Just go through n squared, right? Let's refresh this. For j in range I plus 1 or I length of nums, because they can be equal, right? So, or you can just say for j in range length of nums. So if absolute value of I minus j is bigger than or equal to index difference, and the values is bigger than or equal to value difference, then return this, the first one, right? Doesn't matter which order they're in, there can be multiple answers. Otherwise, you return as it says at the end. So let's submit this. Obviously, n squared is not going to work because this is a 31.7% acceptance rate medium question. So it's a good start, but let's let it time out. Okay, so obviously last few test cases don't pass. So basically what we want to do is find some indices. So the first thought is let's go ahead and create a default dictive list, because there can be duplicates. One can appear at index 0 and 3. So let's go ahead and keep track of where each value appears. So d of the value at this index location. So the dictionary keeps track of that. And then let's go ahead and make some observations. So index difference is 2. Then let's say, okay, so here we have these two as options, right? For here, for 5, we have these two as options, right? So let's go ahead and first iterate like this, and then keep track of everything from the left side. And then let's iterate from 0 to the end and keep track of everything from the right side, right? So here to the end. And then let's see if we ever find a match. If it is, then we can just return it. So that is better than n squared. So to do that, let's first create a sorted list called lefts. And this might take some trial and error, but for I in range index difference to length of nums, let's print nums of I. And then lefts, which is going to start at what? Nums of index difference to the end, right? Okay, so let's see, nums of I is supposed to be 4. Okay, so you're not supposed to have 1 and 4. That's not correct. So this is supposed to be empty, and let's just add nums of I minus index difference. Okay, so at 4 we have, wait, plus 1, I think. Nope. Minus index difference. So now we're starting. Let's actually print here so you can see what I'm talking about. Everything to the left side that's possible. That's like 2 to the left of this and 2 to the right of this. So we're doing 2 n loops. So 1, you have options 1, 5. Cool. 4, you have option 5. All right. So now we just have to find a value that makes the value difference. So between nums of I, what in this side of this left list, let's do this. What inside of the left list is going to be at least absolute value of this? So 1 plus 4 is 5. That's obviously bigger than this. 1 minus 4 is -3. That's less than this. So then here 5 and 1 is 4. So then the index of 5 appears as 0. So it's 1. So what we're going to do is do a bisect left on lefts. And we're going to do one for nums of I plus value difference or minus value difference. This is the absolute value part. Left inside of lefts, nums of I plus value difference. And again, it took me quite a bit of trial and error to find this, but Okay, so if we print BL and B right, so 0 and 1, basically saying from 0 to 1, that's valid. So this is obviously not valid because index 0, which is going to be 5 minus 4, in either direction, or 4 minus 5 is not bigger than or equal to 4. So let's just ask the question, because that's going to be where the value difference is made valid. That's why we did the minus and the plus. So let's say if BL is less than length of lefts. And then this comes in handy because we want to find the original indices. So if absolute value of nums of I minus lefts of B left is bigger than or equal to value difference, then let's go ahead and print D lefts BL, that values 0 and then I. Okay, not subscriptable, lefts BL 0. Okay, is this minus this? Okay. And then let's also do the same thing for the right side. If absolute value of nums of I, because absolute value is always the same, it's always positive, right? Lefts of B right, the same thing, it's just using plus versus minus is bigger than or equal to value difference. Then we print D left B right of 0. We can take any index inside of the locations. So 0 and 3, cool. So at that point, you can see we have our answer, so we just return that, right? And at this point, again, there'd be multiple answers, so that's fine. We just return this. So we're good to go, except we actually have to do the same thing for the right side, right? The right loop. So starting here and then saying these are valid, starting here saying these are valid. So let's go ahead and do that. So right is going to be sorted list of, so index difference to the end, right? And then for I in range up to what? 2, right? Because that's the last, it's valid, or else anything, this plus 2 is out of bounds. So up to length of nums minus index difference. And then here, let's also do the same thing. So bisect left inside of rights this time, nums of I minus value difference. And then same thing, rights nums of I plus value difference. Because let's say you are looking for something that is, if you're on 4 and you're looking for something that the absolute difference is going to be bigger than or equal to 4, then obviously you want to look for something that's bigger than or equal to 8, right? Or if you want the opposite, bigger than or equal to 8 in this case. So let's go ahead and, for BL in less than length of rights, if absolute value of same thing minus rights B right is bigger than or equal to value difference, then we just want to return whatever that index is. It doesn't matter what order it's in, B right, and we can pick any of these indexes because they can be the same, right? For example, here 0 and 0, they can be the same. So that is a little more convenient. So because now we don't have to do a binary search on this again. And so if absolute value of same thing here, absolute value of nums of I minus rights of B, this is B left, B right, return D of rights B right, 0 and I. And then obviously we have to reflect the change. So rights dot discard nums of I minus index difference, or plus index difference, right? Because as we move right, now you got to discard the 4, right? So -1 And let's run this. Nums. And then at the end, if it's not valid, you just return this, right? And okay, this is one of the annoying edge cases I came up with. Basically here, you can see that 52, you actually get 7, right? But the best answer is actually 1 less than that. So let's just say if b left minus 1 is bigger than or equal to 0 and b less than 1 is less than length of lefts. If absolute value of nums of I minus lefts of BL minus 1, which is the 2 instead of the 7, is bigger than or equal to value difference, same thing. Return D of lefts BL minus 1, 0, and I. So let's run this. Cool, let's submit it. Output limit exceeded. Yeah, this one is worth quite a sweat. It's not the easiest thing in the world. A lot of edge cases, but let's see. Time limit exceeded. Cool. This is actually log of n, so let's make this a list. Little trick I know is just to say left is where we're supposed to go in order to insert it in this list at that index. Then you just lefts.insert at L this value. And let's submit it. Okay. Oh, bisect left inside of lefts. Right. Inserting in this order and inserting this value in this order in this list. And there you go. Passes all test cases. So again, I'm really proud of this, that I solved it on my own. Although it's really not efficient. Again, this one was not easy to come up with, but if you get the idea, you can sort of trial and error your way to the solution. So, yep, that's it for this video. Thank you for watching and stay tuned for more.